So let's take a look at what is a system of equations. All it simply means is you have more than one equation. You're solving it, trying to find a solution that makes both things true. So, and of course, when we load this, it doesn't put this correct. It looks like that. It's all as one piece. So in this case, we're trying to find a solution where y is equal to 2x minus 1, which there's an infinite number of solutions there. But at the same time, we want it to make that true and make 3x plus y equal 4 to be true. That's what it is when you're doing a system. You're trying to do more than just one. You're finding the answer that makes them both true, not just one of them. Now, so the solution to a system like y equals 2x minus 1 and 3x plus y equals 4 is finding the one point that both share, which if you think about it, that's going to be the point where the lines cross. So the one line might look like this. And so all those are solutions to the one line. And then the other line looks like this. And all those in blue, that's solutions to that guy. Well, what happens? They share that one point. They have that one point that is on both of them. And that's the point we're searching for. So here's actually a graph of the two. And you can see that what happens, they cross right here at 1, 1. 1, 1 is the point that is on the red line and the blue line. So that's the point of intersection, which is the one point that will make them both true. And that would be the solution to that system. Now, we're going to learn how to do that later on. Right now, we just want to recognize, hey, is this particular point the solution or is it not? Well, how are we going to determine? So here, so would 1, 3 be a solution to this system of equations that I made? So I have two lines, choom, choom, y equals 4x minus 1 and x plus y equals 4. Is the point of intersection going to be that point 1, 3? Is that the guy that is on both of the lines? So if I plug 1, 3 into this equation, would it be true? And plug it in there, would it be true? Well, let's do it. So let's start with the top one. So y equals 4x minus 1. I'm going to plug y being 3 and x being 1. So y is 3. Does that equal 4 times x is 1 minus 1? Is that true? 4 times 1 is 4 minus 1. Yeah, that is true. Well, what if I plug it into the bottom one? X is 1, y is 3. Does that equal 4? Yes, it's true. So therefore, 1, 3 is a solution to this system. And again, later on, we'll learn how to figure out how we got 1, 3. But for right now, we're just trying to figure out, hey, does that make it true? Now, notice this one. This says, would 1, 3 be a solution to this system of inequalities? Not equations, because now we're dealing, in this picture, we're dealing with an inequality. Remember, an inequality is just a greater than or less than symbol. So all we're going to do is plug 1, 3 in and see, hey, does it make this equation true or that inequality true? And what about that inequality? So let's plug it in. Y is 3. Is 3 greater than 2 times x is 1 minus 1? 2 times 1 is 2 minus 1. Is 3 greater than 2 minus 1? Yes. So it makes this guy true. Let's see, does it make the next guy true? X is 1 plus y is 3. Is that less than or equal to 6? Is 4 less than or equal to 6? Yes, 4 is less than or equal to 6. Makes it true. So yes, 1, 3 is a solution to this system of inequalities. That's all we're doing. We're just checking, does the point work? How do we check? We plug it in to see.